that whole idea of the molar ratio there. Continue one more step with another calculation there. If you have a solution that contains 250 grams of water, how many moles of water are present? Well, you've got to know the molar mass for water. You have 2 hydrogen atoms, you have 1 oxygen atom. Add the atomic mass together, you get 18.0152. Round it up to 18.02 if you want to. Okay, so 250 grams times the conversion factor. Well, 250 grams times the conversion factor. Gram goes to the bottom there, 18.02 on the bottom. Each mole is 18.02. So 250 divided by 18 in a sense. That will give you the number of moles, 13.9 moles of water. Next question, how many molecules are present? Each dozen has 12. Each mole has 6.02 times 10 to the 23rd. So this number times 6.02 times 10 to the 23rd, 8.35 times 10 to the 24th. That many number of atoms there. Okay. How many hydrogen atoms in there? Times 2, because 2 to 1 ratio there. If you have this many hydrogen water molecules there, each water molecule has 2 hydrogen in there. Each car has 4 tires. So here you multiply the number by 2. Now pay attention to the scientific notation. In chapter 1, we talked about it. When you write numbers in scientific notation, the scientific notation, the coefficient in scientific notation can only have 1 digit on the left side of the decimal point. That's why these numbers remains between 1 and 10. You see changes in the exponential number here, 23, 24, 25. Every time you, when you convert things into the measurement, into the scientific notation there, you have to pay attention to the format. Now, when you punch in the number in the calculator, your TI calculator may be able to give you the correct form of the scientific notation. That's something that you need to pay attention to. Okay, so these are, at the end of chapter 2, we introduced a giant conversion factor table, periodic table. Using the information in the periodic table, we need you to be able to do these different types of calculations there. So now we have all these tools to count the number of atoms in a sample of an element by weighing it. And the conceptual plan involved in the calculation there is that knowing how many grams of element we need, we can convert them into moles. And knowing how many moles there, we can figure out how many number of atoms in there. Or going the other way, if you know the number of atoms in there, we know each mole